Hello students, welcome to Legacy IAS Academy. So in today's video, we are going to discuss about the fluvial landforms that develop as a result of erosion. That is why we can also call it as fluvial erosional landform. So first of all, let us try to understand that what is the fluvial landform and what are the fluvial erosional landforms. So in simple terms, we can define fluvial landforms as those landforms which are shaped and modified by the running water, such as river water. Running water has sculpted most of the land surface across the world today in comparison to the other agents of erosion such as the movement of the winds and the movement of glacier or ice sheets. Streams, in a simple term, we can say, are in a constant process of shaping the land surface into a newer form, into a diverse form, into various different forms. And thus, running water, because of the force it exerts on the exposed surfaces, erodes and carries particles of varying size, which we also call in simple term as sediment, which can vary in size from a small fine size sediment such as clay to a larger size sediment such as pebbles, stones and cobbles, depending on the slope as well as what is the volume or amount of water that is flowing through the river. So these are some of the factors that affect the extent of erosion, and this also affect that what kind of landform we can expect the river will develop during the course of its flow. So first of all, let us try to understand that what are the processes or various different types of erosional processes that river undertakes which leads to development of erosion landforms. So overall erosional processes can be differentiated into four major types. One we can call as attrition. Attrition refers to such kind of process where due to the flow of rivers, a large amount of rock fragments are being eroded away, are being broken away, and as the river carries this small fragment of these rocks, due to the flow of this river, these rock fragments also collide with themselves, and due to the collision of these rock fragments, they further attrition. There is a further attrition, that means they break apart into much more smaller and smaller fragments. So in simple terms, what we can say that due to the flow of the river, there is a collision between different rock particles, different rock fragments that further causes the erosion, and it is broken down into much more smaller fragment. The second kind of erosion process can be referred as abrasion. Abrasion refers to such process or such phenomena where the larger or medium-sized small rock particle or rock fragment, due to the flow of river, they strike the surface, they strike the river bed, they strike the adjoining areas, and thus causes further erosion of the particular region. For example, if suppose a river is flowing through a mountain, and as this river is flowing through mountain, obviously in the river there is large number of rock particles that is embedded, that has been plucked away in the upper part of mountain. And when the river carries this rock fragment along with itself, it is not only now the river water that will cause further erosion, but also due to the speed and the flow of these rock particles, they will also strike with these rock beds, they will also strike with the hill bed, mountain bed, and thus they will cause further plucking of the rocks or the further plucking of the rock particle. Thus that is what something we can refer as abrasion. The third major type of erosion process is what we can call as solution. Now solution is because we know that river water is not simply pure H2O, that is, it does not have pure water. It also have a lot of different chemicals, different salts, and that is why not only the salt, it also has certain acidic compounds. It has a certain what we can say gases, and thus when the river water flows over certain surfaces which are very much reactive to the materials or gases, or we can say acids, that is when they start to dissolve the surface, and that is what you can call a solution. For example, if suppose the river is flowing over a landform or flowing over a platform which is made up of limestone, so these limestones are very much reactive to the material that is present in the river water, and it also causes the dissolution of this limestone into a liquid form, and that is when you have the formation of sinkholes, formation of caves, caverns, these kind of areas, or this kind of geographical feature you see in the limestone area. So that is what we can call as solution. The last one is what we can refer as hydraulic action. Hydraulic action refers to the action that is due to the flow of the water or due to the penetration of water into the cracks and crevices, and as the water penetrates into the cracks and crevices of these rocks, these cracks becomes much more larger, much more bigger in size, which on a longer period of time can cause bigger crack of the bigger crack, and also separation of the rock fragment into multiple different fragments. So that is what we can call as hydraulic action. So it is via the method of attrition, abrasion, solution, and hydraulic action river is able to cause erosion. and thus in turn lead to development of erosional landforms. So the first erosional landforms that we are going to discuss is in the uppermost part of the river, uppermost course of the river. That is when the river is flowing in a mountainous or hilly region, and that is when the velocity of the river is very high, because obviously the gradient in the mountain is very steeper, and this river is flowing at such a high velocity. This river does not causes erosion in the lateral direction. Most of erosion that happens in the part of the river, upper course of the river, is toward the downward direction, and that is when the river is able to cut the areas more vertically in downward direction, and we have less cutting in the lateral direction, in the sideway direction. And that is why we can see we have development of a valley, a deep areas that takes a kind of V shape. As we can see from this picture here, the erosion, the extent of erosion here is much more lesser. The extent of erosion increases more and more in the vertically downward direction. For example, if you look at the picture here, this is the actual V-shaped valleys that has formed by the Ganga river in the mountains of Himalayas. The nature of V-shaped valleys are simple. They are high gradient. That means the gradient is very steeper because this is steepness of the slope. They are of low order. They are sourced from the springs, rainfall, or sometimes even from the melt. So these are the some kind of valleys we'll see in the uppermost course of the river. Then the other kind of valleys that we see in the upper course of river is something which you can call as a gorge. Now gorge can be defined as a narrow valley having a narrow chasm with a very steep precipitous wall. As you can see from this picture here, if you look at the wall of this gorge, the wall is not slanting, the wall is not slanted, but it is kind of precipitous vertical wall. And that is what makes it different from the valleys. In the V-shaped valley, as we discussed, the wall is having kind of this kind of slope, but in the gorge you have vertical. Second important point or features of gorge is that if you look at the width of the gorge, it is same at its top as compared to its bottom. That means if you move from the top of the gorge to bottom of the gorge, the width changes to a very lesser extent. And as you can see, this is again that makes it different from the valleys, because you can see in valleys what is happening as we are going more in downward direction, more vertically in downward direction, the width is becoming narrower and narrower. So V-shaped valleys are wider at the top, very narrow at the bottom. On the other hand, gorges are of the same width at the top as well as bottom. So this is the second erosion landform that we see in the upper course of the river. The third and similar kind of feature that we see, which we can call as a type of valley, is what is referred as canyons. Canyon is something that look like this, as you can see from this diagram here. The canyon are different from the valley and gorge in the manner that the canyons are wider at the top as compared to its bottom. So in that respect, it is different from the gorge. But what makes it different from the valleys is because the canyon, if you look at that, in valleys we have a kind of similar kind of slope. There's not a lot of variation if we talk about the slopes of the valleys or talk about the slopes of the gorge. But as you can see in the canyons, the slope descend in a stepwise manner. That means as you can see here, you have vertical fall, you have a steep slope, then again gradually we have the slanted slope, then again you have a steep slope, then you have gradual slanted slope, and so and so and so. That means instead of a single steep decline or fall of the slope, in the canyon you have the stepwise manner of stepwise manner of decline of the slope, stepwise manner of fall of the slope. That is what makes canyon different. The most important canyon across the world we know is the Grand Canyon of USA, that has been formed by the Colorado River while it is flowing over the Colorado Plateau. Similarly, in the case of India or in case of the Asia also, we have this river Satluj River that also form a similar kind of Grand Canyon in the Tibet region, which is called as Nari Khorasan Canyon. So these are three different kind of valleys we can say that we see that develops in the upper course of river. The one is the V-shaped valley, second is the gorge, and the third is the canyon. Now, when the river moves further in the mountains or over the plateau, it also forms a landform that we can call as waterfalls. In simple term, waterfalls can be defined as a sudden descent of water or the flow of the river or stream that is caused by variety of factors. The waterfalls are well-known areas because this is also area which attracts a lot of tourists from all across the country and the world, because they're very picturesque and beautiful. As you can see from this given picture here, this is one of the waterfall. The picture that has been taken is from the Ban Giok waterfall, which is situated at the border of Vietnam and China. Actually, if you look at this here, in this side of the waterfall, you have the Vietnam, and this side of waterfall actually is China. And this is, as you can see, example of cascading waterfall, because water is not falling in a single steep slope, it is not falling in single height in single manner, but rather it is flowing over a variety of different areas, or we can say the water is descending in a stepwise manner, giving it a very beautiful and picturesque kind of vibe. So that is what we can call as water. Now, as we discussed, the waterfall can develop due to variety of factors. So, depending on what factor have caused the development of waterfall, we can characterize the waterfalls into four major types. The first kind of waterfalls develop if they are resistant rocks that are laid horizontally. That means what I'm trying to say is, for example, if you have two different kind of rock, the harder rocks are on the upper part, and then in the lower part you have a weaker rock or softer rocks. So if this kind of arrangement of rock is there, and if a river is flowing over through this hard rock, the erosion will be lesser on the hard rock, but erosion will be very more, erosion will be much more significant on the softer rocks. And thus, as softer rock erodes at a faster rate, what happens is we have a development of a steep slope, we have a development of a steep cliff when the water suddenly falls from the hard rock over the soft rocks. The example of Niagara Falls, a well-known fall at the border of US and Canada, is an example of waterfall that has developed due to the horizontal strata of rocks being different. The upper rock is hard, the lower rock is softer in nature. The second kind of waterfall that develops, which is called as vertical falls. Vertical falls develop when the rock layers are arranged in such a manner that we have a hard rock, then we have a soft rocks. So thus, when the river again, when it is flowing over the hard rock and when it enters into the soft rock areas, the soft rock is basically eroded at a very fast rate. And after some time, the hard rock will remain wherever it is, and soft rock will decline in the height. And thus, it will seem that river is suddenly falling from this hard rock over this soft rock. And this is what leads to development of a vertical water. For example, if you look at this particular picture, this is a picture that has developed due to the erosion of the softer rock strata here, while the harder rocks are on both sides of this particular river. And here we have development of the waterfall. This is a picture that has been taken from the Yellowstone River in the Yellowstone National Park of California, which is an example of vertical water. The third kind of waterfall that develop due to tectonic phenomena of faulting and fracturing. Now, faulting and fracturing are simple phenomena where what happens, we have a region that is elevated on both sides, and then we have a region that is depressed in the central part. This is called as horst, and the depressed part is called as graben. In simple term, graben is also called as rift valley, and that is why if from any of this elevated area, if any river is flowing through, if any river is moving through, then they will fall from this horst to this graben, from this horst to this rift valley, and we'll have development of waterfall that can be characterized as fault and fracture waterfalls. To give you an example, one of the most notable waterfalls of the world, that is Victoria Waterfall or Victoria Falls, located in the Zambia region. It developed is an example of fault and fracture waterfall. If you look at this picture here, you can clearly see here we have the horst, that is the elevated area, uplifted area. In between we have a valley, that is a graben, and again this side we have the uplifted areas. And that is why when you have the river that is flowing, Zambezi river, that is flowing over this uplifted area into this rift valley, it forms a very picturesque waterfall. You can see it is very broader in nature all across this rift valley, all along this horst and rift valley structure. The water is falling, so it is making it a gigantic kind of waterfall. So this is the third kind of waterfall, fault and fracture water. The fourth and last kind of waterfall we can define or we can characterize is something that is referred as hanging valley waterfall. That is a characteristic feature of a glaciated region. Now, hanging valley waterfall developed when there was earlier time a glacier was moving through these areas. We have a main glacier and we have then adjoining glaciers. So, since the main glacier has a huge volume of ice, huge volume of ice sheets, the erosion extent is also higher in this main glacier. The extent of erosion is also very higher in the main glaciers, and in the nearby region, the extent of erosion is relatively lesser. And that is why we can see then when the warming period begins, the water of the glaciers start to melt, and the nearby areas also have the adjoining glaciers, that water also start to melt. But since the erosion is deeper in this main valley of glacier, here you will see kind of lake like feature that develops, and from the nearby region, nearby surrounding region, you will see the fall of water that is happening here. The water is falling from here due to melting of glaciers. So these are something that is called as hanging valley, because it seems that you have a valley, and from around this valley area, a lot of water are falling down. A lot of waterfalls you will see that will develop. So it look like it is hanging around this valley, hanging above this valley, and that is the name hanging water valley, hanging waterfalls. So these are the four types of waterfalls that we have discussed. Now, as we move further in the course of the river, the other important erosional landforms that we see developing are called as potholes and plunge pools. So let us try to understand what are potholes and plunge pools. In simple terms, if suppose a river is flowing over any particular area like this, suppose we have a kind of elevated landform and a river is flowing over this area. Now, as we know, river carries large number of rock sediments, rock particles along with itself. A lot of pebbles, small cobbles are there that is carried by river. And when the river fall in downward direction, these pebbles and cobbles also fall in downward direction, and then they strike this particular rock bed. And as they strike this particular rock bed, they can cause a small extent of erosion here. And in this depressed, eroded area, few rock particles, few rock fragments will get trapped. But as the river keep on flowing over this area, these rock particle keep on rotating in this narrow depression that they have formed. And since they keep on rotating in this narrow depression, due to their act of rotation, what they do, they cause further erosion of this depressed area, and this depressed region becomes much more larger in size, much more larger in extent due to continuous erosion by these rotating rock pieces, rotating rock fragments. So such kind of holes that develop in the course of river are called as potholes. On the other hand, when the river and rock are falling at very high speed from a cliff and are forming a waterfalls, here the force that will be applied by the river will be much more larger, and thus you will have a much steeper kind of depressed area or pools will develop, which will be carrying large amount of water and also a lot of rock fragments along with itself. So such kind of depressed area are called as plunge pools. Both potholes and plunge pools are characteristics of the upper course of the river, because that is where the gradient of river is much more steeper, and both of them mostly develop at a bottom of waterfalls as we have just discussed. So these are the potholes and plunge pools. To give you a brief idea, as you can see, this is the actual picture. You have a river that is falling over this hard rock region, and when the river plunges in the form of waterfalls, here due to the action of the rocks, due to the action of water, we have the cutting of the rock bed that happens, and that is what we can call as a plunge pools, where you have a lot of accumulation of pebbles, stones, boulders. The next important erosional landform we have talked about are something which you can call as river terraces. River terraces are also what we can call as old valley floor or old valley floodplains. These happen if river causes vertical erosion of its own floodplain in the due course of time. For example, earlier river was flowing through this particular area. Now, due to the continuous erosion of its floodplain, river has eroded it vertically more, and now river has occupied this particular level. So that means river is no longer flowing at that particular level. Then after that, again river will cause further erosion, and river will leave this particular level and start flowing at this bottommost level. So due to this, what will happen? You will see a kind of a stepwise progression of a landform, a stepwise development of a landform that happens, which resemble like terrace. Now this terrace can be of two type. If the we can see if the terraces are symmetrical on both sides, that is called as pair terraces. On the other hand, if terraces in this particular picture we can see are non-symmetrical on both directions, they are called as unpaired terraces. So that is all about the important erosion landforms that we have talked about as far as the fluvial erosion landforms are concerned. If you like the video, please hit the like button, share it with your fellow aspirants, as well as subscribe to our channel for more such helpful content. Thank you very much.